What if doctors could just print a kidney using the cells from the patient, instead of having to find a donor match and hope the patient body does not reject the transplanted kidney? The soonest that could happen is in a decade, thanks to 3D organ bioprinting. Organ bioprinting is the use of 3D printing technologies to assemble multiple cell type, growth factor and biomaterials in a layer by layer fusion to produce bioartificial organ that ideally imitate their natural counterparts. According to a 2019 study, in the United States, there are 106,800 men, women, and children on the National Organ Transplant waiting list as of March 8, 2023, according to the Health Resource and Service Administration. However, living donors provide only around 6,000 organs per year on average, and there are about 8,000 decreased donors annually who each provide 3.5 organs on average. The cause of the discrepancy is a combination of people who undergo catastrophic health events, but their organs are not high enough quality to donate, or they aren't not on the organ donor list to begin with, and the fact that it's actually very difficult to find a good match, so the patient body does not reject the transplanted organ. Attila and his colleague were responsible for growing human bladder in a lab by hand in 2006 and implanting a complicated internal organ into people for the first time, saving the lives of 3 children in whom they implanted the bladders. About 1 million people worldwide are in need of kidney, so they have end-stage renal failure and they have to go on dialysis. Once you go on dialysis, you have essentially 5 years to life, and every year your mortality rate increases by 15%. Dialysis is very hard on your body, so this is really motivating to take on this grand challenge of printing organs. The main areas where 3D printing can be adopted in medicine are the production of pharmaceuticals and transplants. In the case of artificial organ and tissue production, 3D bioprinters are used instead of typical 3D printers. The 3D bioprinters differ from conventional 3D printers in the spectrum of the inks and that they are able to print. For example, basic 3D printers can only print using thin synthetic or chemical materials such as polymer, plastics, ceramics, metals, and composites. However, 3D bioprinters are capable of printing biomaterials, live cells or cellular materials, using mixed in with polymers. This feature allows scientists to artificially create far more realistic tissue organ structure. Whole artificial tissue organ construct production can be divided into 3 main phases. First phase, computer modeling. Damaged tissue or organ that need to be replaced are layer by layer scanned using computed tomography, magnetic resonance, or other imaging technique. The digital image are then reconstructed into a 3D model. Finally, the model's data converted to a digital language called Standard Translation Language (STL), which 3D printers can interpret. Printing. Firstly, the desired biolink is prepared. For that purpose, cells are isolated from the patient. After isolating them, they are grown in a laboratory in a specially adapted artificial environment, which a required number of cells have grown. They are mixed with polymer to obtain the suitable biolink. which has similar biological properties as the targeted tissue or organ. The bioink is then transferred to a printer cartridge. And finally, the previously prepared STL data is used to print out the 3D model. Post-printing processing. Usually, the manufactured products are not directly transplanted into the organism immediately after printing. This is because the printed organ or tissue construct need to mature to become as similar as possible to the organ or tissue they are meant to place. Therefore, after printing, the products are placed in a bioreactor where they grow for a month or more to withstand the necessary mechanical forces after transplantation and to perform at least the minimum function required for the targeted organ or tissue. Example of 3D printed organ. 3D printed human ear. An ear implanted made from a patient's own cartilage cells and polymeric material collagen hydrogel was 3D bioprinted and implanted into a 20-year-old woman to replace a small and misshapen right ear. Contrary to the traditional treatment method in which the ear prosthesis would have been made from patient's rib cartilage, this treatment is less costly and most importantly required no serious additional intervention with the patient organism. Second, 3D printing cornea. This alternative is the EndoArt 3D printed cornea developed by ION. This artificial cornea constructed is made from a biocompatible sterile polymer. It is dome-shaped, around 50 microns thick, with a curvature that resembles the posterior part of the cornea. This cornea implant received the U.S. Food and Drug Administration (FDA) breakthrough device designation for 2020. 3D printed skin. The French company Wyss and its artificial skin model, Wyss Skin, is best known in the field of artificial skin development. In 2018, the company launched the first bioprinted human full-thickness skin model mimicking dermal and epidermal layer of the skin. Wyss developed skin consists of primary human fibroblast cell naturally found in the dermal skin layer, embedded in a collagen matrix convert with primary human keratocyte. Various cosmetic companies use the 3D bioprinted skin to test their products.